안녕하세요. 데이터브릭스 코리아에서 제조 부문 사업을 담당하고 있는 김양임이라고 합니다. 바쁘신 가운데 오늘 귀한 시간을 내주셔서 저희가 준비한 모두를 위한 데이터 인텔리전스 산업 특집, 제조 산업을 위한 데이터 인텔리전스 웨비나에 참석해 주셔서 감사합니다. 국내에서도 이미 여러 회사에서 제조 현장에서 발생하는 다양한 OT 데이터와 IT 데이터를 결합하고 여기에 AI, 머신러닝과 같은 신기술들을 접목해서 새로운 비즈니스 가치를 창출하고자 하는 디지털 트랜스포메이션에 대한 여러 가지 실험과 그리고 실제 성공 사례를 경험하기 시작한 지도 어느새 몇 년이 지난 것 같습니다. 제조 현장에서는 이미 제조 제품 분량을 컴퓨터 비전 기술을 활용해서 찾아낸다든지 고객이 요청한 불량 원인 분석에 대한 부분들을 이러한 OT 데이터와 IT 데이터의 결합을 통해서 찾아가는 품질 관리 시스템의 보완 등도 그 중에 하나의 사례가 될 수 있겠다 생각할 수 있습니다. 오늘은 약 1시간 정도로 구성된 웨비나로 최근 저희가 데이터 AI 서밋 인더스트리 포럼에서 발표했던 내용들을 중심으로 저희 데이터빅스의 글로벌 제조 사업 부문 리더인 쉽트리자님께서 제조 산업군에서의 주요 챌린지들, 고객들이 겪고 계시는 주 관심 사항들, 이러한 전반적인 트렌드에 대한 인사이트를 좀 전달드리고 데이터브리스에서 준비된 디지털 트윈 사례나 또는 저희 고객이신 포드 다이렉트의 고객 사례 발표를 전달드릴 예정입니다. 마지막으로는 저희 솔루션즈 아키텍트인 장의형님께서 인더스트리얼 IoT 데모 시연을 통해서 센서가 전달되는 IoT 시나리오에서 저희가 과연 어떤 인사이트를 얻을 수 있고 AI 기능들을 통해서 실제 완성 제품이 어떻게 고장이 날 수 있는지를 예지할 수 있는지와 같은 시나리오를 준비를 했고요. 다소 좀 보편적인 시나리오입니다만 그 제조 현장에서 계신 분들께서 유사한 시나리오들을 어떻게 활용할 수 있을지 살펴볼 수 있는 좋은 기회가 될 것 같습니다. 네, 오늘 참석 다시 한번 감사드리고 마지막까지 집중해서 들어주시기 부탁드리겠습니다. 감사합니다.
We have a great session packed for you with great content and speakers that will walk you through how you can industrialize AI-driven innovation inside your companies. Now, the manufacturing industry has a reputation. It's not a particularly good one. It's a reputation that involves the image of turning wrenches. The question in today's age really is, how do you view manufacturing? Do you view it as an industry or as a function? Yes, manufacturing is about designing things. It's about producing things. It's about servicing things. But it's not just about that. It's about innovating. And that's way more than just wrench turning. Autonomy and connectivity are two immensely important trends that are shaping an entirely new generation of software-defined products and factories that generate more and more data every second. Each unit can now be viewed as merely a node in a hyper-connected ecosystem that's opening up numerous new addressable opportunities for real-time optimization, for greater efficiency, and the development of innovative business models that leverage data-driven insights to create competitive advantages and drive growth. One thing's safe to say, there is no shortage of data. Whether it's on products or factories, there's just so much data coming at us, and it's coming at us fast. Every product is now a software product. There's tons of onboard sensors, there's connectivity built into these products, and they generate tons and tons of data, upwards of terabytes per hour, that are exponentially increasing our ability to understand our customers, understand how these products perform, and whether they are actually meeting the primary needs of those customers and help close that gap. Every factory now communicates with the rest of the supply chain, and that has a tremendous impact on how value is created and how things like on-time delivery, things like quality, things like flexibility in production, or even efficiency in how many resources is being used in the production process has tremendous ability to unlock a lot of new gains in that area. I think to sum up why this is such an exciting time for the industry is I would like to use a quote from Jim Farley, who's the CEO of Ford Motor Company, And he summarized this really well in telling us about the transformative time the automotive industry is in and the future of Ford. He said, building vehicles are more like building smartphones in the future. We're about to change the ride, just like Apple and the smartphone companies changed the call. So what's the big deal about that? Gen AI is not the last technological revolution we will see. We've been here before. We've seen industries lose. We have seen industries created. And not so long ago, we were in an era of connectivity revolution. Looking back at the last 20 or 25 years, we can now see how the very nature of value creation changed as a result of this amazing technological revolution. And what you can see very clearly is that the companies at the very top of the stack in apps and data have driven way more profit than any other player in that ecosystem. They've grown 6 times faster than the connectivity service providers and about 2 to 3 times faster than any hardware manufacturer, which I would argue laid the foundation for this connectivity revolution to happen in the first place. In the golden era of AI, my opinion is that the winners in generative AI will capture this economic profit at 2 times the growth rates relative to those companies at the top of the stack in the connectivity era revolution. And it will all unfold in the next 5 years. One of my favorite movies, just to kind of stress on that point, one of my favorite movies recently has been BlackBerry. If you have not seen it, I would recommend you do. The most important dialogue in that movie is not actually from the founders that you see on the movie poster. It's actually from the guy on the right. The guy on the right is Stan Sigmund, who is the former CEO of AT&T. And I think his quote about why he chose to go the direction of Apple versus the direction of BlackBerry, where they were tremendously successful in the past when the phone had launched, is very indicative of the time we are in now in our industry. He summarized in a simple way the risk of being obsessed with the primary unit of production, which is the next machine, the next vehicle, or the next airplane. And in his words, in his industry, he kind of summarized this in a very simple way. He said, the problem with the business model of selling minutes is that there is only 1 minute in a minute. And what that tells us about our industry is that the arc of value creation, and the same thing is going to play out in the manufacturing industry, is that the arc of value creation is going way beyond the primary unit of production. Whether it's the next machine, the next vehicle, or the next airplane, doesn't matter what product you produce. You have to realize that the industry is moving towards using technologies like connectivity, like AI, like data, like generative AI, moving towards solving the primary needs of customers in new ways with an ecosystem approach. What I often chuckle at is the overtly simplistic depiction of the manufacturing industry. Value chain steps that are sequentially organized. It gives a false sense of linearity, which doesn't exist. Well, despite what they teach you in academic settings and thought leadership reports, the business of manufacturing is no longer linear. That's what I'm here to tell you. The product is just a node in a connected ecosystem. The best companies in the world, the most successful ones, have focused on ecosystem building an ecosystem of interconnected services to fulfill their customers' primary needs and delivering way more integrated experiences. As a result, they've created deeper relationships with their customers. They have generated value by defining new engagement models with those customers and delivered way more cross-sector value propositions, which has increased their ability to grow beyond the primary unit of production. And the future in this paradigm is about thinking of products as software platforms and your factories as a node in interconnected supply chain networks. AI shapes a future where where products become software platforms. And products as software platforms are really just delivery vehicles of exceptional features that serve those customers' primary needs and deliver those integrated experiences. Since these products are continuously communicating now, it is way more possible now to help personalize any support offerings that go along with that. And the most important value pool that you can tap onto to help drive a connected product strategy and a support strategy to support it is to deliver features, to deliver value proposition that gives customers their time back. That's the most valuable resource. If you look at the operations and supply chain realm, the goal and AI will shape a future where almost everything is operating on a predictive maintenance paradigm versus a calendar-based paradigm in an era where there is no unplanned downtime in factories. AI shapes a future where quality events or recalls in the field don't happen because computers assist humans in their ability to identify potentially defective products right there in the production process before they ever end up in the hands of customers. And AI can also shape a future where there is no single ounce of energy or resource that is wasted because you buffer the raw materials to only what you need, and you produce and make manufacturing runs only to deliver what you need to deliver. And none of that is possible without good data. The game changers in this industry will drive a comprehensive approach towards industrializing generative AI in their companies. Folks in the industry always ask me, how are companies navigating this journey towards generative AI? Since the explosion of generative AI, companies have begun their generative AI journey and experimented with basic use cases such as providing FAQ chatbots for internal policy documentation or even employee handbooks. The good thing about it is that this strategy has provided quick wins and demonstrated the value of the technology. But what we are seeing is that leaders in this space have not only focused on the simple, but also the strategic areas where their companies can drive unique advantages in their industries, activating their unique data sets and their unique knowledge bases. In short, they're building generative AI applications that only they can build with the data only they have. Leaders in this area are focused on how do you use what we call generative BI to eliminate inefficiencies by providing natural language access to strategic data sets such as the status of supply chain bottlenecks, production performance, and the status of critical industrial processes. This allows for more time spent by the business in understanding where their bottlenecks are and devising recovery strategies to get on-time delivery back on track, and less time spent on wrangling data from multiple systems with complex queries and requiring specialized teams to go model information. The second area, which is an exciting one, particularly exciting one with generative AI, is the use of virtual agents, the development of virtual agents that drive higher productivity by automating tasks, and that is made possible by activating the existing knowledge bases of a company. To take an example, instead of wrangling multiple documents and manuals, field technicians can be guided by an expert assistant that is constantly by their side, enabling quicker diagnosis of potential issues and performing the most effective maintenance action that maximizes uptime and empowers this field staff to support more customers every day. And last but not the least, generative AI will have a tremendous impact in being able to deliver new sources of revenue with AI-enabled services, driving faster cycle times and higher hit rates in innovation. A great example is driving step reduction in design cycle times through the use of realistic synthetic data. And that has really reduced the amount of time and cost that is required to go come up with validated designs of new products. I'll take a few examples of how customers are achieving these results with Databricks. Companies using Databricks are having tremendous success in deploying high-quality generative AI applications in production. Take the example of Chevron Phillips Chemical, a leading petrochemicals company that is using generative AI to digitize and automate order processing tasks, digitizing thousands of orders they get in emails and PDF documents every day. That's making their supply chain and production planning processes that much more effective. And as a result of delivering these generative AI capabilities, they have been able to cut down their order to shipment lead times by over 50%. Take the example of Lippert Components, that is a leading global manufacturer and supplier of highly engineered products. It is training. They've developed a virtual agent to really train their customer support agents and be able to reduce drastically the talk time in their contact centers to the tune of 20% and improving fast. It is enabling their customer support agents to support more customers every day and mobilize their company's existing knowledge bases, whether it's internal support cases, YouTube videos, and even product support manuals. Rolls-Royce, which is a leading aero engine manufacturer, has seen a 30x reduction in design cycle times by using generative AI techniques that are designed to develop realistic synthetic data, reducing the need for expensive traditional simulation studies that cost millions of dollars, tens of millions of dollars, that are typically conducted in the design phases of product development. And now they're able to provide viable and optimized design solutions from a given set of requirements in a matter of hours. Previously, that would take days or weeks and cost tens and millions of dollars with traditional simulation approaches. There's a number of places and resources available for you within Databricks, solution accelerators, blogs, reference architectures for you to get started on the top use cases that we are seeing in the industry, whether it's for field technicians, whether it's product warranty, whether it's in inventory forecasting or logistics. There's a number of different use cases and applications and capabilities to deliver AI-driven features in each of those areas that help unlock tremendous value for your business. I'll leave you with this. We just concluded our Data and AI Summit, where we were lucky to have the one and only Jensen Huang from NVIDIA on stage with our CEO, Ali Ghodsi. One thing that Jensen said really stuck with me, and I think you should keep this at the back of your mind as you go through today's session. Whatever you do, just get started. Generative AI is a fast-moving train. You cannot wait and observe an exponential trend. And I think that's the key to generative AI, is to get started, activate the data sets, the positions, the ability to go deliver these capabilities, and building that muscle is going to set you apart from your competition. Thank you so much for joining the session, and I'll see you in a little bit.
My name is Dalia Alta. I'm a solution architect based in the Benelux area, and I support customers in manufacturing and energy. Today, I will be walking you through our view on digital twins and how can you implement that on the Databricks data intelligence platform. So, what is a digital twin? A digital twin is actually a very accurate representation of your physical object, and it is a virtual model. And to build this virtual model of your physical objects, you need to collect data in a very low latency, so in a continuous mode from your devices, so you can get the most accurate representation of those objects. Now, in a digital twin setup, we're talking about different components. So you have the devices themselves who are producing data. So they are generating a huge volume of data. And this results in a big data situation for enterprises. Then in order to make value out of this data, companies tend to run analytics and advanced analytics and AI use cases on top of them to unlock a competitive value from this data. And finally, you can also tap in this data with a digital twin architecture, so you can have this representation of the model and build also predictive maintenance use cases and other type of use cases on top of this data. So today we will be talking about those two components, IoT data and how do you deploy a digital twin architecture. So let's explore this. Now, as I mentioned, IoT is actually the backbone of a digital twin architecture because it is the starting point. And this can come from factories, so machinery in factories, but it can be also on products which are in the field used by your customers, from the supply chain, so from your providers and third parties that you work with, or from the people and processes within the enterprise. So IoT data is, I would say, when I'm going to mention IoT data, I mean all of those type of systems under the hood, which would make your use cases actually smarter. Now, what is the challenge with creating value with digital twins and IoT data? If we look historically at manufacturing architecture, we are looking into customers who are struggling with siloed data and no existence of single source of truth within the organization. Data is being copied in different systems, BI systems, data lake systems, and the stacks are also not integratable together on a governance layer, but also on a data formats layer. Another challenge there, it is the legacy technologies that are sitting in those enterprises, which actually does not scale correctly, horizontally or vertically, or even present challenges of integration with other toolings. Another challenge, which is very relevant to digital twins and IoT, it is the collection of the data and the ingestion of it. How do you collect data on a low latency and in real-time capability, but also processing it in real time and building machine learning on it in real time? Finally, it is about the collaboration between the different entities. So the collaboration between your data teams and data science teams, and the governance between the two, the ownership of the data, and all of that. If you're having a system which is siloed and not unified, those become very important. Now, if we're looking at today how the manufacturing situation is looking in regards to streaming data and digital twins data, we're talking about data coming from different sources, as we mentioned, application, machinery data, mobile and IoT data, but also data that comes from very valuable IT solutions at a company, which are the SaaS application, on-prem application, and even data warehouses, whether on cloud or in on-prem. Now, the ingestion of the two is actually differs because of the nature of the collection. So you would end up with streaming data collected by message buses from any kind, from Kafka, from the one provided by the cloud providers, but also actually a replication of the data from those systems into the cloud storage of your choice. Now, when you are talking about low latency data, you have different platform than when you are talking about replication of the data. Those are the streaming platforms have different stack, different technology, different syntax and language of programming, and different patterns of architecture. And when you are building machine learning use cases, you are reading from the streaming platforms that you would have, but also from the data lakes, where other data assets that you have. Your data engineers are also trying to stitch multiple stacks together, and ideally you would be also curating data for your business and data warehousing, so you can serve that finally to reporting purposes or other. The serving of the data can happen in multiple forms. Is it for the operational apps, real-time operational apps, real-time analytics, but also back on the edge if you are thinking about ML use cases or other ones. Now, this architecture actually gives us multiple challenges. So you have the siloed version of the data, the duplication of the data, which links to privacy and governance challenges. You have a very complex decision tree for deciding, okay, which type of stack do I use for my workload and which one is the best. Then you have also the integration between those different components, the monitoring of them, ensuring that actually you have governance on end-to-end on your use cases, and making sure that the platform's integration remains compatible on the long run. Now, those are mainly data challenges, but any data, any AI use case actually relies heavily on the quality of the data and the freshness of the data. So this brings us actually into a challenging situation when developing AI use cases, whether it is the classical AI and ML use cases or the generative AI use cases, which are very hot topic at the moment. Now at Databricks, we have the data intelligence platform, which is actually a platform which would allow you to unify all of your data sources into one platform, because we use Delta, which is an open source project we have built to treat any sort of data in the same way. So structured data, unstructured data, and semi-structured data, govern all of those different formats within the same model, so a Unity catalog, and also serve those data assets and models from different point of compute, and also develop AI and ML use cases and streaming use cases on the same copy of the data, on the same governance model of the data. So it is about simplification of the architecture. You have one copy of the data, one governance model, and end-to-end monitoring of your pipelines, as your streaming stack is on the same architecture as your data and AI stack, the same as your data warehousing and data engineering stack. And it's also built upon very open standards and on the cloud of your choice, as we are cloud agnostic. Now, how does this look like? So on the data intelligence platform and the Lakehouse architecture, we are collecting the data from your data sources, the different ones that we have mentioned before, whether it is your IT data, GIS data, or your enterprise data in replication, in incremental ingest, or in streaming. Then this would be modeled into the bronze architecture, a bronze, silver, gold architecture. And this is the medallion architecture we work with. And basically, it is about the quality of the data that you enhance the further you go down the line. So from the raw to the gold being your business aggregates and your data that you would like for your that you would like to use for your ML use cases. Now, the collection of the data can happen by different tools from Databricks. So we work with the Delta Live tables for batch and streaming ETL. We work with Autoloader to make sure that we are getting the data once it gets published on your storage layer within your cloud, or from the message buses. And you can develop from those gold tables or volumes that you have your use cases for reporting, for training your models, or for even integrating with other type of systems. Databricks and the data intelligence platform is being very open, so we can actually interface with many toolings, whether it is in governance, whether it is in analytics or other. And we can explore this a bit later, I think, when we go a bit deeper on the architecture. So if we are looking at digital twins and how do you build that and what are the building blocks, there are mainly two layers. There is the physical layer. So when you are interfacing with your IoT devices or your sensors, and for that you would need to have an edge component that would ingest the data and bring it to cloud, whether it is on streaming or in a bufferized manner, so in a micro batches or batches. Then once the data reaches cloud, of any cloud of your choice, Databricks can then start collecting the data from there, and in streaming fashion, of course, or in batch as you would like it, and then start the ETL in real time, or your analytics in real time, or your machine learning in real time, as you wish. And then you can serve that data. So if we go more in details about how this would look like, IoT Hub here is used to interface with your devices, as we mentioned about the physical interface with your with your IoT devices, then Databricks with structure streaming, which contains Spark structure streaming and DLT, would help you process that data and put it into that medallion architecture that we just mentioned before in Azure ADLS in this case. And you can also use for your in that structure streaming workflows that you're having, or Delta Life tables, models that your data scientists have already published and trained using Databricks. So you can do real-time inference on the data that is coming, and then you can either use that those predictions that you have generated in your reporting use cases, but also to feed them back into your digital twin components, in this case, Azure Digital Twin component, so you can have those visualization of your digital twins. Now, you can, as I said, you can leverage the Databricks capabilities for predictive insights in near real time. You can use Delta Life tables for the real-time ingestion and transformation of your data. And the great story there is that both the model part and the ETL part are now available in serverless. And serverless means that you do not have to do any infrastructure tuning or management yourself, and you can get those machines and VMs ready to use for you and managed by Databricks. So you have a faster time to production and less operational overhead on your teams. Finally, you can serve those results, as I mentioned, in of your digital twin architecture in a digital twin component like Azure Digital Twin, or get the analytics of your transform data in Data Explorer for time series visualization, in Power BI for your insights and reporting, and even other type of applications. Now, if we are looking at real-time capabilities within Databricks, as I mentioned, they are in different parts. So you have streaming and ETL, you have real-time analytics, you have real-time ML, so inference in real time, and you can also use real-time applications to ingest, to actually collect data from Databricks. So you would be using our serverless compute, and your third party's application can collect data from Databricks. As I mentioned about the openness of our ecosystem, in Databricks, we believe in openness. So a lot of part of the architecture is actually open sourced, and we have a lot of partners that we work with closely. I mean, you would have heard from Stardog today, and also other partners. But here is just an idea about the ecosystem that is available out there, from the data ingestion to the some of the connectors that are available there, the governance, or even the utilization of your data. There's also a part in Databricks called Databricks Marketplace, where you can publish data sets that you have curated for third parties to consume. And you can also share data with our open source program, Delta Sharing, where you can share this data to third parties from Databricks. And I think right now we can do a demo. So in the demo, I want to show you actually, so this is the data intelligence platform with the different parts of compute out there and capabilities. And today we will be looking at Delta Life tables, so ingesting data in real time, having to publish dashboards for our users within the business and how they can leverage AI capabilities there, and also use and publish a model on our Mosaic AI compute. Of course, Unity Catalog and Delta are part of this demo too. So if I go into my Databricks environment, I am in a catalog called main. I have my schema, which is about IoT turbine. So I'm collecting turbine data that is coming from a turbine field. And this data is landing in raw in a volume. So you raw files, put it in an unstructured format in volumes. Now, I will be using Delta Life tables, and I will show you that in a minute in order to create the transformations on this data. And I would be using a model that one of my colleagues from the data science team has created and put available in my catalog so I can govern it together with my other assets. So if we go to this, for example, this table, I want to just show you one thing which is very interesting about Unity, which is also about how we make our platform intelligence, is you can start generating descriptions of your tables with a Unity catalog. So if I click on this bottom, it would start giving me descriptions of my columns without me having to read what is inside of it and start to try to explain what is this data. This can help us enhance actually the quality of our data and also the usability of it, as our colleagues might use this table later on, or other people. So I can accept those or hide them or reject them or even edit them if I would like. Now, let's go to Delta Life tables and see what we are doing. So here I am reading from my volumes. So you can see the volume that I just showed you, what it is containing. It is data about, the location of the turbine, the model of it, which state it is, and the ID. Very basic information. Also about, okay, if the sensors are showing abnormalities. And then we are ingesting, actually starting to use SQL type of syntax to ingest the data. So here is our Delta Life table syntax. So we are saying, okay, create a streaming table called turbine. Please check some data quality type of constraints, and read from this volume with this format, and make sure that you have the column names correct. So this is about creating the bronze layer, and then we are creating all of those tables in streaming fashion. Then we go into actually more advanced, and we are transforming the data. So here we are showing that doing some transformation on the columns that we are having, and making sure some of the arrays are written correctly. And finally, we are joining our tables. Now, if we go into the transformations, I want to highlight one interesting thing we can do here, which we can use ML models within Delta Life tables too. And here you can see we are getting the model that our friend from the data science team created, and we are actually putting that on one of the live tables that we are having, which is turbine current status, in order for it to predict if any maintenance would be needed on our turbines. So this is how a Delta Life table can be written. It can be written in SQL, but also in Python if necessary for your teams. And you would end up actually having such a pipeline in the backend where you are collecting data in streaming. You are, all of the transformation that we saw before, you are having it here. You can collect also data quality metrics about, okay, what has been dropped, what has been not dropped, and you can drill down on those. The interesting part that the infrastructure behind this is it can be serverless now since the Data and AI Summit, and you can actually simplify the deployment of those pipelines much further. You can schedule those in continuous or in so for it to be continuously ingesting data or triggered, so on schedule, and you can create them in development and then publish them into production. You can also refresh part of those tables if necessary, if you're seeing some defaults in the quality of the data, and here you can get all of the events that are happening within your Delta Life table. Now, once the data got into, processed by Delta Life table, we get them all here available for us to use in our, I would say in further down the line. So what I have done, I have created a dashboard where it explores those tables that I have built and ingested with the Delta Life table. And it is about actually giving me some metrics about the turbines. And so energy production, how many of the turbines are damaged. This was predicted. The percentage actually of turbines that would have a malfunction, and also some of the type of defaults that are having and their percentage. All of this is great and nice if I know that really if I would like to capture the needs of my users. But let's say some of the users who are consulting this dashboard that has been shared with them within the enterprise would like to ask more questions, and therefore they would be we have a tooling called Genie, where Genie would actually understand the data that has been shared within this dashboard, and you can interact with it in natural language and ask it questions. So in this case, I can I did not get the number. I got the overall number of faulty turbines per aggregated, but I would like to also have it per state. So I can ask it, give me the number of faulty turbine per state. But so I would start analyzing in the backend the data that's been shared for this dashboard, and then it's gonna give it to me this way. I can also choose to to see the code to see really if it is correct, and I can also decide to represent that in a chart if I would look at it. In the meanwhile, we can also download this data in CSV. So this is great. I have my visualization, which I can take it further down the line. I can also ask it to do something even more advanced. And for example, here, I would like to have the average energy consumption per hour per state and the number of faulty turbines in each state. So I can, deduct the correlation between the two. And then it would also similarly give me the results. The access to Genie is still governed by Unity Catalog, and the end-to-end pipeline also. So you are sure that your data is being governed correctly, your model is being governed correctly, and your dashboards too, and the tooling like Genie also. So you are still compliant to your security standards and processes within the company. So that was it for today. I hope you are excited now to try our capabilities with Databricks, and see you next time.
Thank you, Dalia. That marks the end of the Manufacturing Virtual Forum. Thank you to our speakers for sharing their stories. We hope you found the content inspiring and insightful. And if you want to continue exploring the Databricks solutions for manufacturing, please go to databricks.com. Finally, we are thrilled to announce that Data and AI World Tour is back in Europe and would love to meet you in person. We invite you to register on databricks.com. It's going to be awesome. Thank you for joining us today. Bye.
Good afternoon, everyone. Thanks, Shiv. I'm Tom Thomas. I run analytics and AI at FordDirect. So who is FordDirect? We're a joint venture between Ford Motor Company and the Ford and Lincoln dealers within the U.S. and Canada. The majority ownership is Ford, and the majority voting control are the dealers. So we essentially sit in between and serve both the OEM and the dealer franchise network. So the shared goal of the joint venture is to attract, engage, convert, and retain customers as they're interacting at the brand level, let's say on Ford.com, which we call Tier 1, if they're interacting with marketing and advertising at the regional level, which we call Tier 2, or if they're interacting with the dealers digitally or in person with what we call Tier 3 in the automotive space. So in order to do this, over the last 25 years, we've really become a trusted advisor and primary digital solutions and system provider to the dealers in support of sales, service, inventory, parts, and accessories. So if you've ever shopped for a Ford and Lincoln vehicle and you're on the dealer's website, that's a FordDirect website. If you've ever clicked on a display ad or done a search or received an email or a direct mail from your local Ford dealership, that's likely going through a FordDirect agency. And if you're at the dealership and they're capturing your customer information, looking up inventory, scheduling service, likely on a FordDirect system. So we don't build or develop these systems directly. What we do is we partner with best-in-breed technology providers that are out there in the dealer automotive space. And so we can give those dealers choice amongst a variety of companies to serve in that channel category. So for example, dealers can choose from one of 6 advertising agencies if they're on the FordDirect advertising program. Now, the main benefit for the dealers is by helping plug them into a larger data ecosystem that allows them to connect with their customers more effectively and efficiently. So with each partnership that we do with FordDirect, we're requiring a back-end integration to those partner systems so we can capture the inbound and outbound customer signals and bring those into our Databricks Lakehouse. So for example, we're streaming roughly 1.3 million visitors and all that website activity that they do across 3,500 websites a day. We've got 16 million ad impressions through the advertising channel, through roughly 12,000 daily connections that we've built. We're tracking about 2.8 million in-store signals across the dealer CRM systems. We can see about 780,000 vehicles across all the dealer lots, and about 400 of those vehicles on average transfer between the dealerships every day when a customer wants something different that the dealership doesn't have. And then we capture roughly just under 200,000 leads a day, which turns into about 690,000 phone calls where we bring in all those transcripts for analysis. So we have this highly scaled and holistic view of the customer, the vehicle, and service activity across the channels, across dealers, and across those tiers I mentioned. It's also really the largest source of single source of customer data across any automotive OEM and franchise dealer network that we're aware of. So now over the last 3 years, we've started to transform our Lakehouse into more of a customer-centric system where we've started to unleash those signals for the same customer, and we started to stitch those together in a time series fashion to create what we're calling like a customer journey record. And we have about 90 million unique customers that are now stored in what we call our customer journey platform, or CJP, and there's about 1.7 billion unknown journeys that we're continuously trying to ID and consolidate. And so with that amount of history, signal variety, and volume, it's highly statistically significant for machine learning and AI. So we continuously feed those journeys into a scoring layer that we can use for next best action strategies, as we call it, to help enhance our partners' product solutions as well as do new product development. So that brings me to the purpose of my organization. We have both external and internal objectives. Externally for our dealers and retailers, it's providing them that holistic view and single view of the customer journey while still allowing them choice for channel partner providers. For our FordDirect partners, it's giving them access to an unprecedented variety of customer signals in which to enhance their products with, and being able to deploy those economically with a single integration into our system versus going dealer by dealer and hooking into all their backend systems to do the same thing. And for Ford Motor Company, we're enabling more efficient and effective customer experience by connecting cross-tier journey signals, tools, and data science. Now internally, inside FordDirect, I'm responsible for producing BI and AI solutions to measure the performance of our products, support better business decisions, creating journey and AI-driven core product enhancements for new product innovation, and producing analytic data solutions as corporate assets for monetization. How do we do that? So you can see these are our departments that fill up the funnel with requests, where each of those is managed through an intake process that, or something might warrant our project management office if it's an extensive effort. Our production and operational disciplines are then brought to bear across business intelligence, data engineering, data science, machine learning, and AI, and platform operations, all supported by a cross-discipline team responsible for data strategy, governance, and monetization. We then consume our data inputs needed for these requests, and we utilize our tool environment to develop solutions. We have a legacy set of tools to fulfill a variety of needs, and some of these are moving towards a more centralized AI platform, which I'll talk about in a moment. And those data inputs are then managed in our Lakehouse in our unified governance environment. And finally, we produce our internal and external solutions. On the external side, those monetized solutions of data as a service, analytics as a service, and software as a service to our constituents. So now on to our spotlight solution. So it starts with a problem statement about how harnessing data at the dealership can be a full-time job. And at FordDirect, we've spent years consolidating many of our dealers' data silos into a single platform that actually we own, that's in our environment. However, within each individual dealership, it's still a farm load of silos. So you can imagine many roles within the dealership still have to access multiple systems and dashboards to do their jobs. Next time you're in a dealership, you just look at all the tabs they have open across multiple screens at a desk. It's a lot. So our dealer advisory board to FordDirect is number one request to us right now is to help dealers simplify their business. And as you can see here, last thing they probably don't need is another dashboard. We also ask them about their use and their understanding and experimenting with AI solutions that are out there in their marketplace. And most of them are using direct revenue generating solutions that are customer facing, that are on 24/7. So texting AI to the customer, email AI, generative responses and communication to them. But then you see on this third spot is better analytics and BI to try and solve that problem that I just spoke about. So last summer, when some of the first open source LLMs became available and manageable within a secure pipeline architecture, we built a solution that harnesses that disparate data within the dealership and want to give that back to them from our system with quick insights that they've never had before. So introducing the FordDirect Dealer Copilot, and I'm just going to go ahead and let it speak for itself. So volume.
Today, accessing valuable business information is a time-consuming and labor-intensive process, requiring dealers to manually search multiple databases and reports. Copilot does the work for you and is a single point of access to consolidated data that eliminates the time, expense, and hassle of manual data mining. The introduction of Copilot empowers dealers to make smarter decisions by providing access to a wealth of data and predictive AI-generated insights.
Hi, Dealer Copilot. This is my first time using you. Can you tell me how you can help me and my dealership?
Hello, I'm here to help you make informed decisions and improve your business by providing information based on customer reviews and dealership data. I can help you understand your sales history, website activity, service operations, and customer sentiment. For example, I can tell you which cars are most popular among customers or provide information about the inventory levels of specific models. I can also help you understand customer activity and interest, as well as provide insights into repair trends.
Moving Explorer inventory is a key focus area for me right now. Let's take a closer look at the Explorer inventory. Show me the VINs for our in-stock Explorer vehicles.
Here are the VINs for in-stock Explorers. I have grouped them by PEP code to easily see which trim packages are remaining on the lot the longest.
I'm curious if we have enough demand. I'd now like to see what customers I can follow up with on their recent Explorer lead. Which of my customers have submitted a lead for an Explorer in the last 30 days?
There are 5 unique customers that have submitted a lead for an Explorer in the last 30 days. I have included a column for their sales propensity to help prioritize who to reach out to first. The customers with a high propensity are most likely to purchase. Also included are the latest actions taken by both the customer and the dealer.
I wonder if there are customers that have viewed an Explorer online but have not submitted a lead recently.
There are many customers that are indicating they are interested in an Explorer based on their website activity. Several of these customers also have a high propensity to purchase with no recent action from the dealership, making them ideal customers to contact.
Let's try asking about this line of reasoning in a single prompt. Show me the VINs for our in-stock Explorer vehicles and the customers that have signals indicating interest in an Explorer but have not submitted a lead.
I was able to query your inventory, website activity, and leads data. Provided below is a list of your Explorer inventory along with customers that have shown interest without submitting a lead.
Thank you, Copilot. You've uncovered opportunities I wasn't aware of and helped prioritize which customers to target.
Glad to be of assistance. My intelligence is continuously expanding, so please share any feedback you have about me with the FordDirect team.
Today, Copilot provides users with convenient access to a wealth of information from multiple sources, offering insights that inform better decision-making. Looking ahead to tomorrow, we envision Copilot automating dealership processes and enabling dealers to proactively respond to new data and insights, creating efficiencies and driving business forward.
Okay, so thank you. Yes, so we're getting there. As per the video, I want to reinforce, the value that we're starting to see today and tomorrow with our pilot for the Copilot with a small set of dealers. And today, when it comes down to it, it's really helping the different roles in the dealership do their job. Tomorrow, the way we see it is it starts to do the job, right? Or at least parts of the job, or at least the more mundane tasks. So again, it's that moving to that near future notion where labor is spent less on repetitive task-based operation and more on cognitively driven growth. And so ultimately using AI to automate the dealership. So here's a high-level view of our inference architecture. Like I said, when we started this journey last year, I would consider it pretty early to try and develop an enterprise Gen AI solution that's using both proprietary data as well as publicly available social media data. So when we started out, we had endpoints on AWS's Inferentia servers, which were compiled to their own standards. The SQL was generated in Domo, which was our BI tool, and our sample data set was also in Domo. And so it made the users have to pick from the different data sources they would ask questions from. And that we were able to use those tools quickly to put together a proof of concept that allowed us to move forward with the main system that we have today. And so that's where Databricks handles concurrency for all the parallel requests and model versioning. We're now accessing the full customer journey platform in our gold layer within Delta Lake. We're using Databricks hosted foundational models for our agent workflows, result summarizations, chart visualizations that you saw there in the video, and the vector indexing. We're using MLflow for our self-hosted code-generating LLM and our own FordDirect Databricks environment that's fine-tuned for SQL generation. But my favorite piece of this is this React framework where it's sort of reasoning plus action, where we're using DBRX up front for generating the pipeline instruction set for which models or data sources to use that we're just now calling tools to bring to bear to kind of answer each part of a compound prompt from the user. So this architecture allows us to quickly switch tools in and out without changing the overall flow structure. When it comes to handling current challenges that you hear about when developing the solutions today, no control over the data or models. So our entire solution, logging models, data are also self-contained in the Databricks instance. To managing sort of inaccurate responses, we're using RAG, single, and multi-shot prompting to improve the output quality. So it's basically, we're doing an upfront comparison against a vectorized prompt database that we include as examples to refine the original prompt before sending it to our SQL code LLM. In terms of managing performance, we're using MLflow with provision throughput, so we have that sort of guaranteed capacity there when inferencing the more fine-tuned foundational LLMs. And then in terms of managing expense, we're using Databricks' serverless infrastructure, so we don't have to pay for servers with expensive GPUs up and running all the time, and we're minimizing our self-hosted LLMs. And then for getting through the testing process, we're using the Databricks inference tables, so we can record specific information from the user requests, and we're using the live Lakeview dashboard for monitoring everything. And then lastly, how do you manage scope with these? So it's a challenge, right? You really need to bring, strong software architects that have that experience, product and project management, and the best AI expertise that you can find. You can't find too many people who have been doing this for more than 8 to 12 months at this stage. So it's right, you take your MVPs and you organize, your prompts library of what's going to be an MVP 1, your feature set where you're doing, single turn, multi-turn, how you're capturing feedback, and then you have your data sources, right? And you organize it by that way. And the way to really understand how to contain each of those elements in those categories is to bring the users up front, right? So we have to bring dealer users who are, prompting this with what they're experiencing during the day, with what their behavior is, and you really have to set their expectations because the responses come back in all kinds of different ways. And they're not used to that when they're doing user acceptance testing for more traditional applications. So they just have to be used to that they're actually sort of training a child or a toddler, so to speak, to get it better. And that helps us control where that scope's going. And then lastly is, evaluating the business value of the solution, right? So always asking the why, the what, the who, the where, from the standpoint of, is there a market for this? What is the commercialization value of that? And then your scope's always adjusting to those needs. So a few features on how we're ensuring the response quality. So, intelligent and governed automated access to the data source, right? So we're building in the data access controls at that agent layer that are aligned with FordDirect security policy. So making sure dealer data doesn't cross between dealership entities. That also helps us avoid additional prompt engineering when we're QAing the SQL results. We're also doing detailed and thorough search functionality during the RAG step. So language is ambiguous, prompts can also be muddled with dealer terminology and automotive terminology. So we do a semantic search using Databricks vector search on social media data wherever we're doing the response generation for that. And so the way we prep that up is we use an LLM that basically creates 5 permutations on the user's prompt. And then we blend those into one optimized prompt based on semantic vectors before we, that actually brings out more of the meaning of what the customer is looking for before we send that to the vector search step. And then lastly, we're using data-guided controls for post-response. So storing all the correct responses into a database can be used going forward for that multi-shot prompting and future prompts before we send it to LLM code generation. And then recursively improving responses where models failed. So using user feedback to help train a judge LLM that corrects those responses and again stores them into a place for future RAG. So lastly, this is our evolving FordDirect AI strategy and architecture. So at the top are our AI-driven strategic initiative pillars that either maximize business efficiency by coming up with custom AI applications to improve business operations across internal departments, as well as elevating our strategic thinking and starting to shift our culture, or maximizing revenue by using AI to reimagine product innovation, our OEM, our services back to the OEM, and ways to directly commercialize data. Now that central AI platform in the middle is what I'm most excited about, because as we started developing the Copilot, we started to realize how its architecture could be reused for a variety of inference-based business applications. So that React or agentic approach allows for a more modular flexibility across user access profiles, RAG templates, models, structured and vectorized data, and really sort of treating them all as tools. So therefore, we don't have to start from scratch when we want to develop a new logic structure for each new AI solution that might go beyond, say, the Copilot. So, in the near future, if you visit a Ford or Lincoln dealership as a shopper or for service, hopefully whoever you're working with will call upon their AI assistant to answer any questions that you may have wherever you are on the premise to maximize your experience and hopefully get you into a Ford or Lincoln vehicle. So thank you for your time.
안녕하십니까. 오늘 모두를 위한 데이터 인텔리전스 산업 특집 제조산업을 위한 데이터 인텔리전스 웨비나에 참석해 주셔서 감사드립니다. 마지막 세션으로 저는 인더스트리얼 IoT 데모 시연을 통해 실시간으로 유입되는 센서 데이터를 수집하고 머신러닝 모델의 생성과 배포를 저희 데이터브릭스 플랫폼에서 어떻게 처리하는지 데모를 통해서 간략히 소개해 드리도록 하겠습니다. 오늘 데모는 폭력 터빈 예측, 유지 보수입니다. 저희가 구축할 것은 여러 소스로부터 실시간으로 데이터를 수집하는 IoT 플랫폼을 구축하는 것입니다. 이 정보를 바탕으로 분석가는 고장 전의 폭력 터빈의 소리를 사전에 식별하고 이를 미리 수리함으로써 에너지 생산량을 증가시키는 그런 시나리오라고 말씀드릴 수 있겠습니다. 원천 소스가 있다면 이 소스들은 저희 데이터브릭스 플랫폼에 테이블로 저장이 되고요. 저희는 이때 인크리멘탈하게 로드를 하실 수 있도록 오토로드를 제공해 드리고 있습니다. 그리고 이것은 시간 단위로 어그리게이션 하게 되고요. 그리고 이것을 또 머신러닝 모델을 만들기 위해서 트레이닝 데이터셋을 만들게 됩니다. 그리고 여기서 AutoML을 통해서 만든 모델은 저희 데이터브릭스 플랫폼에 등록되고 그리고 배포함으로써 우리가 현재 문제가 발생할 터빈을 어떤 특정 컬럼에 추가를 하겠죠. 그렇게 해서 테이블을 만들어 놓고 이것을 바탕으로 BI 대시보드를 만들어서 이제 사내 구성원이 공유하는 이런 시나리오라고 생각하시면 되겠습니다. 실제 저희 플랫폼에서는 이렇게 파이프라인을 구성해 봤습니다. 이렇게 부품 데이터가 있고요. 센서 데이터들이 이렇게 스트리밍 테이블로 들어오게 되면 이것을 이제 시간 단위로 이렇게 어그리게이션 하고 이것을 과거 데이터를 어그리게이션 해서 그리고 터빈의 메타 데이터를 다 통합을 해서 이렇게 트레이닝 셋을 만들게 됩니다. 그리고 이것들을 바탕으로 머신러닝 모델을 만들고 이것을 특정 테이블에 현재 문제가 발생할 만한 터빈을 보여주게 하는 그런 테이블을 이제 만들게 되는 시나리오입니다. 이렇게 트레이닝 데이터를 만들게 되는 이 플로우가 전체 수행이 되게 되면 이렇게 테이블이 만들어지게 되는데요. 이 테이블은 저희 데이터 플랫폼 내에서 이렇게 보여지게 됩니다. 그 테이블의 컬럼이나 타입이 보여지게 되고요. 그리고 이 테이블이 어떻게 만들어졌는지 DDL을 보여드리게 됩니다. 샘플 데이터도 이렇게 보실 수가 있고요. 네, 이렇게 샘플 데이터 형태가 나와 있죠. 그리고 특징적인 것은 이렇게 저희가 이 테이블이 만들어지는 리니지를 자동으로 구성해 드립니다. 이렇게 컬럼을 전체를 보실 수도 있고요. 앞에 어떤 테이블들을 통해서 이제 데이터가 들어왔는지, 그리고 이런 것들은 컬럼 단위로 이렇게 추적이 가능하게 자동으로 이런 리니지가 구성되게 됩니다. 이렇게 테이블을 만들고 나면 이것을 가지고 AutoML 모델을 적용하는 것은 굉장히 간단합니다. 익스페리먼트라는 이 머신러닝 메뉴를 가서 AutoML에 Create AutoML Experiment를 기능을 사용하시고요. 우리가 처리할 클러스터를 선택하고 터빈에 문제가 발생하는 것은 클래시피케이션 모델이 되겠죠. 그래서 ML 프로블럼 타입은 클래시피케이션, 리그레션, 포캐스팅 중에 이제 클래시피케이션을 선택을 하고 트레이닝 데이터셋은 저희가 아까 만들었던 여기에 터빈의 트레이닝 데이터셋이 되겠죠. 셀렉트를 하고 그리고 프레딕션 타겟은 이렇게 문제가 발생하는 에버노멀 센서를 이제 저희 프레딕션의 타겟으로 이렇게 선정을 해놓고요. 그리고 이 밖에 어드밴스드한 옵션으로는 이렇게 이블레이션 매트릭 같은 것들을 지정할 수 있고요. 프리시전이나 ROC 커브 같은 것들, 그리고 타임아웃, 이렇게 여러 가지 옵션들을 지정하실 수가 있게 됩니다. 이것을 가지고 스타트 AutoML을 하면 이제 이게 수행이 되겠죠. 시간이 좀 걸리기 때문에 제가 미리 수행해 둔 결과가 있습니다. 이렇게 IoT 수행 결과를 보면 이렇게 트레이닝을 많이 해뒀고요. 저희 AutoML 기능이 재밌는 것은 실제로 AutoML을 돌리고 나시면 그 이터레이션을 돌면서 정확도가 아까 선택한 건 이제 F1 스코어를 선택했죠. 거기에서 가장 좋은 퍼포먼스를 냈던 그 소스 코드를 이렇게 노트북으로 제공해 드리게 됩니다. 이 노트북을 클릭해 보시면 이터레이션을 계속 돌면서 이제 우리가 타겟으로 했던 그 F1 스코어가 계속 증가를 하게 되겠죠. 이 노트북에 보시면 This is an auto-generated 노트북이라고 해서 이제 시스템에서 자동으로 제너레이션한 노트북입니다. 그래서 데이터를 어떻게 로드했으며 어떤 형태고, 그리고 컬럼들, 그리고 프리프로세싱을 어떻게 하는지 같은 소스 코드들, 그리고 컬럼의 타입별로 너머리컬 컬럼, 카테고리컬 컬럼, 어레이 컬럼들 이런 것들을 이제 다 플로팅 값으로 다 변환을 시켜야 되겠죠. 이제 그런 것들을 어떻게 처리를 했는지, 그리고 트레이닝 밸리데이션 스플릿을 어떻게 했는지, 클래시피케이션 모델을 트레이닝하고 이런 절차들을 다 여기에서 이렇게 보여드리게 되면서 뭔가 새로운 머신러닝 모델을 만드실 때 이 모델을 바탕으로 이제 새롭게 커스터마이징 하시면 머신러닝 모델을 만드는 시간을 굉장히 단축시키실 수 있을 겁니다. 네, 그리고 이렇게 모델을 만들고 나서 특정 이터레이션을 또 이제 살펴보면 이 이터레이션에 이렇게 매트릭 같은 것들, 어떠한 것들이 나와 있는지 관련된 정보들을 굉장히 자세하게 보여드리고 있고요. 그리고 여기 아리팩에 가시면은 이 모델의 패스, 그리고 이 모델을 적용시키기 위한 코드의 예제 같은 것들도 다 보실 수가 있게 됩니다. 네, 그래서 이렇게 모델을 만들면 우리가 이제 터빈에 문제가 발생한 가능성 같은 것들을 이제 머신러닝 모델을 만들었죠. 그래서 그 머신러닝 모델을 먼저 활용하기 전에 현재 그 터빈의 상태 같은 것들도 이렇게 대시보드로 만들 수 있을 겁니다. 그래서 현재 그 터빈을 하나 골랐습니다. 이렇게 하나 고르면 이 터빈이 지금 생산하고 있는 에너지 양, 그리고 터빈의 모델, 그리고 이게 헬시한지 문제가 있는지, 그리고 시간의 흐름에 따른 에너지 생산량, 그리고 터빈이 가지고 있는 여러 센서들이 있기 때문에 그 센서들의 각각의 전류량, 그리고 그것의 디스트리뷰션 같은 것들을 보실 수가 있습니다. 이 대시보드를 하나 만드시면 여기서 바로 이렇게 진이라는 기능을 제공해 드리는데요. 바로 질문을 해 보실 수가 있습니다. 이렇게 제가 미리 질문들을 만들어 뒀는데요. 에너지 생산량이 가장 좋은 터빈을 위치 함께 보여줘 라고 하면 이제 뭐 이런 식으로 보여주게 되고요. 도시별로 에너지 생산량을 보여줘 라고 이런 것들도 이제 충분히 가능합니다. 이렇게 하면 이제 이 표를 나타내기 위한 쿼리 같은 것들도 이제 보실 수가 있고요. 그리고 재밌는 것은 이렇게 피드백을 주실 수가 있습니다. 포지티브 피드백, 그리고 네거티브 피드백, 그리고 이렇게 이 대시보드를 만든 사람한테 질문 같은 것들도 하실 수가 있겠죠. 네, 여러 상위 12만 보여줘, 이런 질문들을 마찬가지로 수행하실 수 있습니다. 그리고 또 다른 대시보드에서는 문제가 발생하는 그런 터빈들에 대해서 좀 보여주는 대시보드입니다. 그래서 센서에 문제가 예상되는 터빈들의 목록, 그리고 그것들을 그대로 뒀을 때 향후 24시간 에너지 생산량의 예측, 그리고 네, 그 센서들이 이제 사용하는 부품들이 있기 때문에 이 부품들이 어떤 것들이고, 이런 부품들을 이제 구매를 했을 때 리드 타임이 얼마나 되는지 이런 것들도 나타냈습니다. 그리고 지난 1년간 장애가 발생이 반복되는 부품들은 어떤 것들인지 뭐 이런 것들도 대시보드를 표시하면 도움이 되겠죠. 대시보드를 만드실 때 이렇게 만들고 자연으로 이렇게 대시보드의 그래프를 표현할 수도 있습니다. 그러니까 뭐 예를 들면 에너지 생산량을 보여줘 이렇게 한다면, 네, 여기에 현재 OK 정상인 상태의 터빈들이 생산하는 에너지양, 그리고 문제가 있는 터빈들이 생산하는 에너지양 확연히 차이가 나죠. 이렇게 내추럴 랭귀지로 그래프를 표현하실 수도 있습니다. 네, 제가 간략히 보여드렸는데요. 이렇게 저희 데이터브릭스 플랫폼에서는 데이터와 관련된 여러 가지 기능을 이 밖에도 많이 제공해 드리고 있습니다. 요즘 유행하는 뭐 LLM 같은 것들도 포함해서요. 만약에 오늘 제가 말씀드렸던 이런 문제들을 현업에서 만약에 가지고 계시다면 언제든지 저희 데이터브릭스 플랫폼에 연락 주시기 바랍니다. 네, 감사합니다. 감사합니다.